chlorine residual analyzers. So what is my best choice? I'm going to help you determine what might be the best choice for you in a chlorine residual analyzer. We normally do these training sessions in-house. We have a training center, our impact center, instrumentation, measurement, process, automation, control, training. And that center is pretty well closed right now. We're going to start opening it hopefully pretty soon with the COVID thing going on. So we're doing these virtual trainings instead. So thanks for signing up. I've got another one going on next week on the same day at 2 o'clock in the afternoon on flow metering. So the objectives today, we're going to talk about the types of analyzers and the different technologies. We're going to talk about application concerns. We're going to talk about the cost of installation and maintenance. And we're also going to go over the final thoughts. And then afterwards, we'll have a question and answer. So we should wrap up around 9:30. It's about a half-hour presentation. And then you can hang on for a while. I'll stay online here to take any questions. So chlorine analyzers were introduced in the 1960s, and the type of analyzer at that time was called an Amperometric analyzer. It was actually developed by Capital Controls Company back in the 1960s, and I'll show you that type. There's now a lot of different types of technologies. A lot of different types of technologies are available now. We'll go over those. They're used for monitoring control of chlorine, basically. Water, wastewater, and industrial processes. It's used in a lot of different areas there. These analyzers are very sensitive to the application, so we want to make sure that you have the right application, the right analyzer for your application. First type of analyzer is called an Amperometric Cell type analyzer. This is the original. It was developed by Capital Controls back in the 60s, and basically the sample comes into the analyzer right in this area, and it flows down this tube and goes up through a cell. Inside that cell, close up here shows that there's two different metals, copper and gold. When you add chlorine to water, it forms hydrochloric and hypochlorous acid. When you put that acid between two dissimilar metals, gold and copper, it forms something similar to a battery. You'll actually have a very small voltage produced. There's a wire connected to the gold, there's a wire connected to the copper, and between those two metals, as the sample flows through the cell, you have a small voltage created, and that voltage can be interpreted as a concentration of chlorine. So that those two wires then tie into this control unit, and that converts that voltage over to a reading of parts per million of chlorine, or milligrams per liter. The sample must be pH controlled, so there's a reagent used. It's glacial acetic acid, and that glacial acetic acid flows into the analyzer through a small feed mechanism here, and a small drop of that reagent goes into the cell every few seconds. That pH then is driven down to a pH of 4. The other thing that's important is there's a thermistor here that measures the temperature of the water to be sure that it is stable. The parameter that needs to be controlled in this analyzer is the pressure of the water. So this cell is what's called a constant head device. As the water fills the cell, it overflows a weir and goes to drain. And that maintains a steady pressure in the cell. So with these analyzers, amperometric analyzers require stable pressure, stable temperature, and pH. And that is what's used to measure chlorine. And these analyzers are good for water treatment, they're good for wastewater, and they tolerate solids very well. So this is the only type of analyzer that I personally would recommend for use in wastewater treatment. It's very forgiving, it's easy to clean. There is maintenance involved, but most of the other analyzers aren't that suitable for chlorine for wastewater. And this analyzer does require reagents. If you're reading free chlorine, you just simply have chlorine with this analyzer. You need to add potassium iodide in order to read total chlorine. The other type of analyzer is what's called a colorimetric DPD type analyzer. I think most of you are familiar with measurement of chlorine in your laboratory using a small portable laboratory DPD analyzer. You take a sample, you put it into the device, you push a button, you get a 0. You add a DPD reagent to the sample, put it back in, and you read it. Very simple. It basically, they're sending a light through the cell at a certain frequency, and it reads the color of the sample to determine what the chlorine residual is. So this type of analyzer uses that same method. It does it automatically in batches. So inside this analyzer is basically a cell similar to it's a cuvette, similar that you would use on your laboratory unit. Water enters in through this pressure regulator, goes through a solenoid valve, and a sample is directed to the cell. It shoots a light through the cell, takes a 0 reading. There's a small pump on the front of here. This is a solenoid driven pump that applies a certain amount of reagent to that cell. The cell then, it's a DPD reagent. The cell then changes color and it shoots a light through that cell again and reads your chlorine. The display up here reads how much chlorine is in the water, parts per million. And it does that again after a period of time. This whole process takes anywhere from 1 minute to 3 minutes, depending on the settings and how often you want to get a reading. And that reading is then can be sent as a 4 to 20 milliamp signal to your SCADA system or to a chart recorder. This particular analyzer is good for water treatment. It's really not the best thing for wastewater, but some of our wastewater is very clean now. So a good quality wastewater, tertiary, possibly wastewater, this analyzer could be used for that. It does not tolerate solids very well, and because of the small orifices and tubing that are in here that can easily get fouled. That is the colorimetric DPD type chlorine analyzer. And this does require reagents. These reagents have to be refilled on a monthly basis. The other type of analyzer, which is becoming more popular, is an Amperometric Probe type analyzer. These probe analyzers essentially use a probe that's in a cell. And that probe is very similar to the Amperometric analyzer, the first one I showed you, but it's a little bit different in that the cell is encapsulated. So this is the tip of the sensor is platinum, and this part of the sensor is silver oxide. So you have two dissimilar metals, silver oxide and platinum. Inside the cell, this cap contains an electrolyte solution. It's like a gel. And so these two dissimilar metals are submerged in that when this cap is applied. And there is a membrane on the tip. That membrane allows chlorine ions to enter into that electrolyte solution, and it causes a charge, just like the first analyzer that I showed you between the two dissimilar metals, the platinum and the silver oxide. That charge is then turned into a signal that can be used to measure chlorine. This particular analyzer has the same requirements as the first analyzer, and then it's got to have a steady pressure, it's got to have steady temperature and pH. The electrolyte itself is a stable pH, so that's not an issue. You don't need reagents then, because the electrolyte is managing that. And by the way, that electrolyte only needs to be replenished every 6 months to a year, and we recommend replacing it once a year. You take the cap off, clean out the cap, and put in new reagent. This analyzer requires a steady flow also. So your water would enter in, go through a rotometer where you can adjust the flow rate. This one happens to have a pH probe as well, and then it flows through, comes down and enters into the cell, and there is a constant head device here as well. So as this fills the cell, it overflows and goes to drain. That provides a steady, constant pressure. And with this analyzer, it's very important to have a steady, constant flow across the tip. And the temperature is compensated for internally. This probe actually produces a 4 to 20 milliamp signal that comes out and goes into the transmitter and is converted into parts per million. This analyzer is good for water. It's not good for wastewater. The main reason is that it's sensitive to ammonia. And we all know that ammonia is not uncommon in wastewater. So there may be some new technology that will overcome that, but for now, I would not recommend a probe type analyzer for wastewater. The membrane has to be replaced. I would suggest once a year. I've seen them go much longer depending on the quality of your water. It does not tolerate solids very well because the membrane can become fouled. When these probe analyzers first came out, everyone was very excited about the concept of just sticking this probe into a, for instance, chlorine contact tank for wastewater. The problem with that is that you need to have a constant flow at a steady flow rate across the tip in order for it to work properly. And you can't always be guaranteed that in a open tank. It does not require reagents, so there's a big savings there. Water treatment, this is an excellent analyzer. This analyzer is approved by the EPA. When they first came out, these analyzers, EPA said they couldn't be used for reporting, but that was changed because most of the manufacturers went to them and said, look, it's the same as the amperometric analyzer, it's just that it's in a probe style. And so they did approve it, but you have to do a 2-week test when you first install it, comparing it to your laboratory instrument to be sure that it is accurate. So be aware of that. If you're using it for water treatment, you're going to have to go through this 2-week period when you first install it of testing it and reporting the results. So in summary, Amperometric Cell type analyzer, Colorimetric DPD type analyzer, and Amperometric Probe type analyzer. So a couple questions. Does the Amperometric Cell use reagents? Yes or no? Does it tolerate solids? Yes or no? Water and wastewater? And so let's just answer some of these questions. So the Amperometric Cell type analyzer, if you said yes, it does use reagents. And this bottle needs to be replaced once a week. Does it tolerate solids? Yes, it does. The Amperometric Cell analyzer. And yes, it is good for both water and wastewater. Colorimetric DPD, it's good. It does use reagents, does not tolerate solids, and it's mostly used for water treatment. And your amperometric cell probe type does not use reagents, does not tolerate solids, and it's mostly used for water treatment. Let's look at the costs related to each of these analyzers. So the amperometric cell type analyzer, in my research, showed the lowest cost of about $3,300 for the instrument, and $55 is the highest. You can get all kinds of accessories for these. For instance, you can get a peristaltic pump to feed in this reagent rather than using a bottle, so you can have a larger volume source. Installation can be anywhere from $1,000 to $2,500, and some of that depends on your sample point. You need to have, obviously, water flowing to this analyzer, and so you may have to have a sample pump. You may have to run tubing or piping, and is it going to tie into your SCADA? So there's costs associated with all that, anywhere from $1,000 to $2,500. So for this amperometric cell analyzer, anywhere from $4,500 to $10,000 for that analyzer installed. The colorimetric analyzer, priced at about $3,200 on the low side, $4,300 on the high side. Accessories, again, it mostly depends on your sample location, where you're going to mount it, and installation costs, similar issues. So in this particular analyzer, it's going to be about anywhere from $4,300 to $8,800 to install this analyzer. The Amperometric Probe type analyzer, lowest cost I was able to find is $3,500, highest $7,500. Accessories, you can get pH probes to go in there. You can there's a lot of different accessories you can get for this, anywhere from $100 to $2,000. Installation is about the same as the others, and this one, from a capital expense part, is about $4,500 to install. On the low side, $12,000 on the high side. There's a lot of different options you can get on the high side. So let's look at the operating costs for these analyzers. Amperometric cell reagents are about $1,000 to $1,800 annually. Parts, $100 to $1,000. These analyzers have a motor. This analyzer has a motor to keep the cell clean. There's a little more mechanics going on here, so this requires a little more maintenance. Labor, I'm reflecting that in the labor here also. That analyzer does require attention more than the others. About $1,200 on the low side, $1,800 on the high side. So total operating costs annually about $2,300 to $4,600, depending on your particular application. The higher the chlorine residual that you're reading, the more reagent you're going to need for measuring total chlorine. Colorimetric cell, $850 on the low side, $1,000 on the high side. Parts, anywhere from $100 to $1,000. You have to replace the little pump tubing on that. There's also maybe a new cuvette you would need on an annual basis. Labor for maintenance, anywhere from $1,000 to $1,800. So a little bit lower cost of operation for the DPD analyzer, anywhere from $1,900 to $3,800. Amperometric probe type analyzer, reagents are only about $25 to $50, and that's really for the electrolyte that you would replace every 6 months to a year. Parts, anywhere from $100 to $500. That's mainly the membrane cap for that probe. Labor, maybe $1,000 to $1,800 on that particular analyzer. So from cost of operation, that's the best deal there. That Amperometric Probe analyzer at about $1,100 on the low side to $2,300 on the high side. So let's look at the summary here of the different costs. So which analyzer has the lowest capital costs? The Amperometric Probe type analyzer. Which analyzer has the lowest operating cost? Would be the probe as well. And which is your best for application? Amperometric Cell type analyzer, wastewater. Colorimetric DPD analyzer, clean wastewater or water, mostly water. Amperometric Probe type analyzer, water only. So just a few final thoughts here. You need to consider the cost, obviously. Consider the type of analyzer based upon your wastewater quality or your water quality. Very important. Sampling point, how you plan to get the sample to the analyzer. Think about that. You might have to pump it. You might have to put in a line from another part of the plant. Think about also the distance, because if you're going to use this analyzer for control purposes, you want to have that sample location in the right spot to get good feedback for your control system. Using these analyzers for control is pretty common, but you have to really give it some thought, and we can help you with that. Just let us know if you are interested in that. Is there a drain available? All of these analyzers require a drain. You have to have water, obviously, feeding into the unit, but then that's got to go somewhere once it passes across the cell. So be sure you have a drain available to take that. We did have an installation at a remote pump well site where they didn't have a drain. So they wanted to drain it back into the well. And since the probe analyzer has no reagent, the thought was that that's fine, but that's not fine. That electrolyte solution that's in the probe analyzer is considered a reagent, and it does leach out through the membrane very slightly, and that would not be allowed to go back into your well. So you'd have to use a different type of method to drain. In this particular application, they actually went through the floor of the well station, and they made a little drain field outside to drain that sample. Will the analyzer output a signal to your SCADA, and where are you going to tie? If you're going to tie it into the SCADA, where are you going to connect? There should be an I/O, an input-output panel somewhere in your plant where you can tie that into your SCADA. Consider the capital and operating costs, obviously, and consider a pilot or trial. I would highly recommend doing a trial study, especially if you're using an analyzer for wastewater. Wastewater, especially industrial, that has any industrial feed, can have an effect on the amperometric analyzer. Anything that changes the conductivity of the wastewater can cause a slightly different reading on the analyzer and cause erratic operation. So I recommend doing a trial. Ask your supplier for assistance. Obviously, we can help you with that.